Audrey Hepburn once said, "Water is life, and clean water means health." Water covers 70% of the Earth's surface, and yet 2 billion people around the world do not have access to clean water. To solve this problem, we have decided to design a solution to purify water and make it safe to drink.
Take a look at Niger, one of the least developed countries in the world. With a population of around 27 million people, around 54% of Nigerians do not have access to a source of clean drinking water, and water-related diseases are one of the leading causes of child mortality. We believe that by engineering a solution to filter all the harmful pollutants out of the water, we could save millions of lives, not just here, but across the globe.
Before we begin designing our own solution to this problem, it is important to first take a look at some of the existing technologies that are used to filter and clean water. Currently, one of the most popular methods in the world to clean water is filtration technology. This can come in many different forms, with the most efficient being reverse osmosis.
Reverse osmosis works by forcing water molecules through a semi-permeable membrane, which removes the contaminants from the water and purifies it. While efficient, it requires frequent maintenance and is extremely expensive to run, meaning that it would be very difficult to introduce on a global scale.
As a result, we turn to desalination, which is another method of water purification, similar to distillation, which is fully powered by the sun and requires very little maintenance. Our CAD model here depicts a water tank with a sheet of thermal insulation permeated by small holes placed a couple of centimeters from the surface of the water level.
The heat from the sun is absorbed by this black material, which then radiates the heat to the water, heating it up. The water then evaporates and turns in purified water droplets on the top of the tank. Due to the tilt, these water droplets then collect on the pipe as shown here, and then can be used as safe, drinkable water.
The reason why this design is better and more efficient than other methods of water purification is due to the fact that it does not require frequent maintenance or expensive running costs. The permeated layer encourages natural convection currents, causing thermal localization, and therefore is more efficient at conserving heat. Furthermore, since salt water is denser than pure water, the majority of the salt sinks to the bottom and then can be carried away through a separate pipe. This prevents salt buildup and hence eliminates the need of frequent maintenance.
On a final note, the research sources that we used for this project are shown here. In order to make sure that our research was valid, we used reliable information from reputable sources such as MIT and UNICEF. Thank you for watching, and we hope you enjoyed this video.